Okay, so this lesson we are looking at simultaneous equation models. Your learning intention is to use simultaneous equations as models and to solve problems using intersecting graphs. Okay, so simultaneous equation models use two linear functions to describe a practical situation, and the point of intersection is often the solution to a problem. Okay, so this is where we're actually solving a problem using simultaneous equations. First example says Zaina buys and sells books. Income received by selling a book is calculated by using the formula I equals 16n. Costs associated in selling a book is calculated using the formula C equals 8n plus 24. Alright, part A says what is the income when 6 books are sold? So we can use the formula for this. Income equals 16n. So 16 times the number of books, which would be 96. B is what is the cost when 6 books are sold. So cost equals 8n plus 24, which is 8 times 6 plus 24, which is $72. Okay, now draw the graph of I equals 16n and C equals 18n plus 24 on the same number plane. Now I've already set up my axes to save a bit of time. Income and cost I've put together because they both represent money, and they're my y-axis, and n is my x-axis, which is the number of books sold. Now, let's use a gradient intercept form. So for the first one, I'll do two different colours. Income equals 16n. Now my y-intercept here is 0, and my gradient is 16 over 1. Okay, so 0. My gradient is 16 over 1. So 16 is about here. So let's just try to be a little bit more accurate. I'm going to call that halfway. And you'll notice as soon as you stop being accurate, your graphs won't line up properly. And this one's got unusual numbers. Okay, so that's that. And then 1 over. Now be careful. Because my axes are set up at different intervals, make sure if you're going 1 over, you're looking at that. You're not just assuming it's one box. In this case, you're lucky, but it's not always the case. Okay, and I don't really like that I've put that X there because that's not a point, so I'll take it away. Alright, now if I join these two lines, or these 2 points, sorry, I'll form the equation of that line. I'll just fix it up so it crosses. Really not good at drawing a straight line anymore. And you need to get them right because... Okay, that'll do for now. We can fix it up later. Alright, so that one is income equals 16n. Now the other equation, I'll do it in green, is C equals 8n plus 24. So C equals 8n plus 24. My y-intercept is 24. And my gradient is 8 over 1. So coming up here at 24. So again, let's set up those axes. That's halfway. So 24 is there. So I'm going to call that my point roughly. And so the gradient we said was 8 over 1. So we have to go up by 8. So it takes us up to about 32-ish, which would be there. And then over by 1, which is here. So there's my second point. And you will also notice that when we set up your booklet, oh, sorry about that, we gave you 4 quadrants. You only really need, a lot of these situations, you only need the first quadrant because it's all positive when you're dealing with money. So you don't actually need to draw all 4 of them, you can just draw 1 quadrant. Okay, so there's my second line. Which is C equals 8n plus 24. Now, to answer the question, oh, that's part C, sorry. Part C was just to graph it, so I'll just put this working for part C over there. Now, part D is asking, use the graph to determine the number of books needed to be sold for the cost to equal the income. So, that point of intersection we're looking for, the number of books. Let me just double check that my equations are nice and accurate. I don't really have a nice clear intersection point because it's 3.5 books on my graph. You can't sell 3.5 books, obviously. So you are going for 3 books. Okay. Now my axes are a bit off. It should come closer to 3. And I'm actually going to in a second do this on Desmos just to double check. So according to this equation, we're looking at about there. Okay, so that is 3 books. Let's chuck them into Desmos very quickly. Now Desmos over here. Got that from the last example. Okay, so let's clear that one off. So the first equation was I equals, and we need to put in those coordinates. So I was y, remember? So y equals 16 x, and the other one was y equals 8x plus 24. Okay, so where are we? So the way that the axes are done makes it look really unusual, but we can find that intersection point. It's about there, and you'll see, look, it's 3. Okay, so if I hit it with your mouse, it'll tell you what the coordinate of that intersection is. Okay, so it's at 3, so it's definitely 3 books. Okay, now example 10. Example 10 is a tricky one because I'm not actually giving you the equations. Example 10 says, Isabella's mathematics marks exceeded her English mark by 15. She scored a total of 144 for both tests. Find Isabella's marks in each subject by plotting intersecting graphs. Okay, so let's call English E and mathematics M, okay? And I've already set up my axes ready to go. Now we know that Isabella's mathematics marks exceeded her English mark by 15. So mathematics equals English plus 15. Okay, so whatever she got in English plus 15. Now her other one is the total of 145 for both tests. So mathematics plus English equals 145. Now let's graph. So the first one's in orange. My gradient here is 1 and my y-intercept is 15. My gradient in this one is, we need to rearrange, so I'm going to go green, minus e, so my m equals minus e plus 145, so my gradient is minus 1 over 1 and my y-intercept is 145. Okay, so if you have a look at what we have here for our gradient and our y-intercept, you will notice that it's going to be really hard to plot that. You can't really plot a gradient of 1 over 1 when your axes have such big gaps between the intervals. So we're going to have to go with another way. Alright, so we can graph for both of them the y-intercept. So I can graph 15 pretty easily, and I can also graph 145 pretty easily. Now instead of using the gradient, what I'm going to do is I'm going to substitute another point in. I'm going to say what happens when I have 100 books. Okay, so I'm going to, when E equals 100, so M equals 100 plus 15, so it will equal 115. So at 100, over here at 100, I'm going to go up, and I want to go to about, and at 100 I'm selling 115. So 115 is about there, correct? So I'm going to call my second point for the orange there. Alright, and hope that is accurate. Alright, now down here, I'm going to do it at 100 again. So M equals minus 100, plus 145, which will equal 45. So at 100, for my green graph, down here at 45. So it's about there. That's about 45. Okay. Ooh. So I'm gonna cross those there. Alright. Now again, we might have to pop into Desmos at the end just to double check this, because it's a lot of estimating of spots on my graph because my axes are set up in this way. Ugh. It's being a bit stubborn with my line. Okay, we're just going to go with that and hope for the best. Alright, and the next one. Okay, now we have a point of intersection, which is here. Okay, so our point of intersection is about there. So we're going to call that about, that's 70, so let's say that's about 65. And it's very clear on the 80. So that's our point of intersection there. Okay, so from that one, you should hopefully have worked out. Sometimes gradient intercept form doesn't work perfectly. The y-intercept is very clear, so usually a very good point to go off. But if the gradient is hard to plot, just substitute another point into your equation. Okay, and yeah, hopefully that makes sense. With these questions as well, feel free to be using Desmos as you go to double check your answers. It's a really good resource. All right, thank you.